Welcome back to another episode of Who Wants to Be a Mathematician. I'm your host, Mr. Hill, coming at you with some AP Calculus review of doing derivatives. So this is going to be a mid-assessment. We have some more derivatives coming on after this assessment. But before the break, let's take the test and let's see how we do. So this is going to be the solutions to the practice test that I handed out. So here we go. Starting off with 1, we're finding derivatives of each equation, and we don't want to simplify. We just simply want to find the derivative. So if I have this equation, I'm going to rearrange it to be cosecant x squared times sine 2x. So now I got a couple things going on. I got one function times another. So when I'm looking for the derivative, I'm going to be using the product rule. And product rule says take the derivative of the first times the second plus the derivative of the second times the first. So this function is going to be my f of x. This is going to be my g of x. So I take the derivative of the first. Now when I take the derivative of the first, I have a couple things going on. I have a function on the outside, I have a function on the inside. So this is going to be my first function, this is going to be my second function. So when I take the derivative of two functions, I use the chain rule. So this is going to be f prime of x times g of x, and I'm going to add g prime of x times f of x. That's what I'm looking for. So f prime of x is, I'm going to do the outside, which is 2 times cosecant x to the 2 minus 1, but 2 minus 1 is just 2. And then I'm going to times by my second function, the derivative of the inside, which is going to be negative cosecant x times cotangent x. So this whole thing here is my f prime of x, because I have the derivative of my first function times the derivative of my second function. Now I need to add on the derivative of g of x. Well, the derivative of g of x, I still have two functions here. My first is going to be the sine, and my second is going to be the inside. So outside and inside. Take the derivative of the outside first, so that's going to be my cosine 2x times the derivative of my inside, which is just 2. So again, this is my number 1, and this is the derivative number 2. And there we have it. So the final thing is going to be 2 cosecant x times negative cosecant x times cotangent x plus cosine of 2x times 2. Oops, I forgot to multiply by my cosecant squared. So then this is times cosecant squared. Ooh. All right, so that's number 1. Numero dos, or 1b, I guess you could say, y is equal to tangent x squared. Notice where the squared, it's on the x, it's not on the tangent, plus e to the 2x. I'm looking for the derivative, so I'm going to use quotient rule. We're going to have to use quotient rule for this. So quotient rule says low d high minus high d low all over low low. So I'm going to take my bottom, which is secant x plus e to the 2x. I'm going to times it by the derivative of my top, and I have an outside function, I have an inside function. So again, I'm going to do the same thing. Derivative of the outside is going to be secant squared times x squared times the derivative of my inside, which is 2x. So that's the low d high, and now I have my high d low. Oop, let's get rid of some of these things here because they're in my way. Oh, come on, go away, go away, go away, please. Go away, you little dot. Yes, all right. So that's my low d high. And now my high, which is tangent x squared times the derivative of my low. So I'm going to take, since I have a plus, I have derivative of this plus the derivative of that. And inside this part, I have an e to the u times du, where 2x is u, du is 2. So I have derivative of secant is, anybody? Secant tangent plus e to the 2x times 2, because the e to the u is my first, and then I multiply by my derivative of my exponent. So all of this is all over secant x plus e to the 2x squared. So let's move on to 1c. I guess instead of calling it 1, 2, 3, 1, 2c. Alright, so y, I'm going to rewrite my equation. Originally it's x plus the cube root of 4x plus 1 squared. Ooh, this is a doozy. So I'm going to have x plus 4x plus 1 to the 2/3 all to the 1/2. All I did was just rearrange. Now I need to pick out my functions. I have this one. Let's do it differently. Pick out my functions. I have number 1. I have number 2. I have number 3. And I have number 4. So all in all, I have 4 different functions, so I'm going to have 4 different derivatives. So let's start. I always start from outside inside. So I start with my 1/2 x plus 4x plus 1 to the 2/3 all to the negative 1/2. That's my first step. And then I multiply by the derivative of number 2. Derivative number 2 is going to be 1 plus. Now this is where this third and fourth part comes in, because I'm going to have 2/3 let's undo. Come on, one more. 4x plus 1 all to the negative 1/3. That's my number 2. So number 2 and number 3 are kind of together, because when I take the derivative of this part, I bring my outside down. And the very last step is timesing by the derivative of my very inside. So if we were to recap, this would be my first derivative, this would be my second, and then this part right here is my third, and this is my fourth. 2 and 1. So that's my derivative. If you don't like the pink stuff, we can take it away. Bye, bye. Oh, 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 go on, go away. There, that's my derivative. Alright, number 2, find the limit of each expression. So this is 2. Oh, this is 2. So we have the limit as x approaches 0 of 2 cosine x minus 2. I don't know why I have that there. Let's get rid of that. All over 3x. So I notice that there's a 2 in my exponent, so I'm going to have the limit as x approaches 0 of 2 times cosine x minus 1 all over 3x. Well, see, I don't like the fact that it's cosine minus 1. I don't like that at all. So I like 1 minus cosine. So I'm going to change this into the limit as x approaches 0 of negative 2 times 1 minus cosine x all over 3x. And I can rearrange this to be negative 2/3 times 1 minus cosine x all over x. And I know this part goes to 0, so 0 times negative 2/3 gives me 0. Letter B. B, 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 B. Limit as x approaches 0 of x cosine x minus x squared all over 2x. So I want a 1 in there somewhere. So the first thing I'm going to try is I'm going to try factoring out. So x cosine x minus x all over 2x. Well, that doesn't really help me. I mean, I guess you could, because I could cancel out these x's and I'm just left with limit as x approaches 0 of cosine x minus x all over 2. And I'm going to try plugging in. So cosine of 0 minus 0 all over 2, so I have 1/2. So let's do c. There's a trick to c. So this is the limit as x approaches 0 of 3x minus sine 2x all over x. And I split this up, so limit as x approaches 0 of 3x over x minus sine 2x over x. And I know this goes to 2, and this goes to 3 because the x's cancel out. So I'm left with 3 minus 2, which equals 1. Pretty straightforward stuff. There's little tricks in there. I guess it's not straightforward. It's a little bit tricky. But we'll just keep moving on, just trucking forward. X plus b when x is less than 1, x is greater. I messed that up. Come on. X is greater than 1 and less than or equal to 1. Alright, so we're trying to find if it's differentiable. So first is it continuous? Well, for it to be continuous, my two sides are going to have to equal each other when x is equal to 1. So at our fancy dancy point right here, so when x is 1, that's when they have to equal each other. So I'm going to have a is equal to 1 plus b. The step 2 is, does the limit as x approaches my 1 of my left hand side equal the limit as x approaches 1 of my right hand side? So I need to find a derivative. So I'm going to take a derivative. So f prime of x is equal to is equal to 2ax and 1 when x is greater than 1, x is less than or equal to 1. So then I set both of those equal to each other. So I have 2ax is equal to 1 when x equals 1. So I can plug in 1, so I get 2a is equal to 1, a is equal to 1/2. So if a is equal to 1/2, then I just take this value and come back here, and I have 1/2 is equal to 1 plus b, so b is equal to negative 1/2. So I have my b, I have my a, and I am happy. So 4, determine if the cube root of x minus 2 is differentiable for each of the interval. So a is going to be on negative 3 to negative 1. B is going to be on 0 to 3. And C is going to be on negative 1 to 0. So what I'm going to do is I'm going to look at this function right here. So if I graph this function, I know that the parent graph looks like this. This brings it down 2. So 1, 2, and I have something like this. And my key feature here is right here. I know because I'm the cube root that I am not differentiable. So I'm not differentiable at x equals 0. That's what I'm not. So now I just need to check these intervals that I have over here if x is in it. So x is not in, so when x equals 0 is not in this interval, so the answer is yes, this is differentiable. X is in this interval, so it's not differentiable. And x is not in this interval because we have a curly bracket, so this is a yes as well. So yes, no, yes. So letter 5, good. Number 5, we have a graph going on. It looks like this, and it asks, given this function f, we're going to determine where it's not differentiable. So not differentiable. So we know it's not differentiable if it's not continuous. Well, it's continuous everywhere, so we tried that first. And the second part is the whole limit thing. If we're approaching it from the right-hand side of our derivative is equal to the limit as x approaches our left-hand side of our derivative. So if we look at a derivative, we're really looking at right-hand side slope. Whoop. Is equal to left-hand side slope. So that needs to happen. So if I'm looking at here, this slope is different than that slope. So right here at this point, it's not differentiable. This slope is different than that slope, so that means right there, right there, right there, at all of your parts where you're not the same slope. So all of these parts, and it's just those 4 values. So it says determine where it's not differentiable. So I would say at, what is that, -2, 1, at -1, 2, at 1, 2, that's this one, and then this would be at 2, 1. So I'd give those points. Not differentiable. So for number 6, we have a graph. Not a graph, a chart. I don't know why I said graph. Let's see if I can... Oh, that's not terrible. So 1, 2, 3, 4 parts. We have our derivative at x, our function at x, and we have our x value. So this is 0, 2, 1, 1, -1, 3, 2, 3, 4. And it says if h of x is equal to f of 2 minus x, g of x is equal to f of 2x plus x, k of x is equal to h of x times f of x. I'm going to do, I want to find a h prime of 2. Well, in order to do that, I'm going to have to take the derivative of h. So that's going to be f prime of my outside times the derivative of my inside, which is -1. So I'm just going to plug 2 into here, so I'm going to get f prime of 2 minus 2 times -1, which is f prime of 0 times -1. So I come up here, and I find my f prime column, and I find my 0 column, and I want to find f prime of 0, which happens to be 1. So I would get 1 times -1, which equals -1. B asks us for g prime of 1. So I need my g prime. G prime of x is equal to f prime of 2x times 2. I'm going to put it out front, and then I have plus 1 because of that. So I'm going to plug 1 into my equation. I'm going to get 2 times f prime of 2 plus 1. So I'm going to get f prime, which is, let's do this color. So f prime of 2, I'm looking down my f prime column. I'm looking down my 2 column, and I get 4. So this is 2 times 4 plus 1, which equals 9. And last but not least is C. I'm going to cramp it up over here, sorry. I'm looking for k prime of 0. So that means I have to find my k prime. Well, I have the product, so derivative of the first times the second plus derivative of the second times the first. And I plug in 0, so I'm going to get h prime of 0 times f of 0 plus f prime of 0 times h of 0. So I need to look at my different columns here. And it just so happens that so if we, h prime of 0 is going to be this piece here. So h prime of 0 is equal to, I plug in 0 here, so f of 2, so I look at my f of 2, and I get 4 times -1, so this is going to be -4. And then f of 0 is my next piece, so I look at my f function, I look at my 0 function, I get 0, I get 2. Oh, I look at this, and I get 2. So this is 2, and I said the other piece was negative 4 times 2. And then now I'm going to add on f prime of 0. Well, f prime of 0, so I look at my f prime column, and I'm looking at 0. Again, it's 1. And h of 0. So I come over to my h of 0 and get f of 2 minus 0, which is f of 2. So I look at my f column, I come over to my 2, and I get 3. So this is going to be negative 8 plus 3, which gives me negative 5. Number 7. So I'm given this function, an alien runs a 50-meter dash, so 50 meters, that's where I'm going to run 50 meters, so that the distance is modeled by this. So A says find the average, so I'm looking for velocity average over the interval 1 to 4. So this is going to be my f of b minus f of a all over b minus a. So, oh gosh, mental math. So this is going to be 16 plus 20, so 36 minus 1 plus 5, which is 6 all over 3. So this is going to be 30 over 3, which gives me 10. So my average velocity is going to be 10, what is the meters per second? B, it says find the instantaneous velocity. So I'm looking for a derivative. So this is going to be 2t plus 5 when t is equal to 4. So this is going to be 8 plus 5, which gives me 13. That's going to be my instantaneous. And then it says find the velocity at the end of the dash. So I dashed 50 meters, so that's the distance. So if I come down here, see, I'm going to have 50, because that's my total distance covered, is equal to this. So then I'm going to have 0 is equal to t squared plus 5t plus 50. Oh man, I wish I thought about this before. 5 and 10? That's not going to do it. Oh, this is embarrassing. I should have factored this first. What is it? T squared plus 5t plus 50. This is embarrassing. Solve, please. Don't fail me now, internet. Oh, internet, please. Quickly, the viewers. Why is this not working? Oh, man. Oh, this is so embarrassing. Well, it's probably something simple that I'm just not seeing off the top of my head. 50 to add up to 5. So ridiculous. Come on, internet. Here we are. Oh yeah, these are totally not. What? Oh, Mr. Hill, you're a moron. Why didn't you tell me? This is minus 50. Alright, does that change anything? I don't think it changes anything. It might change something. Come on, computer. Yeah, it gives us messiness. What? Oh my gosh, I'm so bad at this. Okay. This would be plus 10, and this would be minus 5. That's why. Okay. So I have 2 times. I have a negative 10, and I have a 5. Well, it's not going to be my negative time, because I can't have negative time. So once I have this, I plug this into my velocity, which is my 2t plus 5, and I get 10 plus 5, which is 15. And that's my answer. Oh, that was a little bit embarrassing. Alright. We're going to move past that real quickly. Let's get right past that, because we don't want to dwell on that whatsoever. And the embarrassment of Mr. Hill. Yikes. Number 8. Given the function f of x is equal to 1/2 sine 2x plus 1. I want to A, find my derivative and find my double derivative. Alright, so I have 1/2 outside function cosine 2x times inside function, which is 2 plus 1. So this can be simplified because my 2 and my 1/2 cancel out. So this is cosine 2x plus 1. Oh, just kidding. The 1 goes to 0 because you take a derivative of it. So that goes away. Jeez, I'm just not on my game. So now I'm looking for derivative of this. Outside would be negative sine 2x times my inside is negative 2. So my outside, my inside. It says find the equation of the tangent at this point. So pi over 2 comma f of pi over 2. So I'm looking for the equation. So I'm going to plug my x value, which is pi over 2, into my derivative. So this is going to be cosine of 2 pi over 2, which is cosine of pi, which equals negative 1. So my slope equals negative 1. So I'm going to have y minus, I'm not going to do this out because I don't want to embarrass myself again, times x minus pi over 2. And that's my function. Last but not least, sketch the line at the point P. So it gives me something that looks like this. So I would come over to pi over 2, and since this is a sine curve at pi over 2, it's going to be my top, and I'm going to sketch my line of going like this. Ta-da! And there you have it, folks. See you tomorrow for the test!